Dear architects, the title is mouthful, but I will explain you what we can do simple way here in the system of systems, how we can architect them simple. So let's start with an example which I think even people in US can experience. So this is a cutout of a map of Zurich transportation systems. As you can see here in this corner, we have various transportation systems in Zurich. We have trams, we have buses here, in this case, electrobuses. We have trains for commuting from, suburbs to the city and in the city. We have cable cars. Zurich is, kind of like hilly city. We have ships going on the lake, and we have ships going on the river and the lake. They are the broken lines here. They are usually lower so that they can pass under the bridges. So that's the difference. And we can even add another public transportation system. For example, the rental bikes. So this is systems of systems. So we have the typical situation that we have existing system of systems which have various functionality. They have various quality attributes. For example, the performance of the train is much higher than the performance, the speed, let's say, of the ship, and the train is also less. The availability of the train in terms of weather is higher than the bike. And there are various interfaces. There are stations. There are stations, with escalators for transporting for some luggage. So the problem statement here is how to implement a process, in this simple case, moving from point A to point B, using the existing systems like the tram, bus, train, cable car, ship, and etc., or introducing a new system into the play, and how to design the interfaces, how to use the stations. Well, I'm not in the business of public transportation. This was an example which I hope you can identify yourself with. So I'm working for Roche Diagnostics. And then just shortly, what we are doing, what are our systems of systems? First of all, we are doing the chemistry and the instrumentation for medical diagnostic, for the in vitro diagnostic. In vitro means in a tube, like the blood in a tube, for which you send to the laboratory. And the systems as big as me. They are tabletop systems. They are small systems which you could put in a pocket potentially or put in a pharmacy. And there are systems which are coupling a lot of the instruments of the system components into something which would definitely not fit in this room. So here is one real example. Most of the systems are from Roche. This is a laboratory from Brazil. So Brazilians, you can be, if there is somebody here, can be really proud. One of the biggest systems in the world is in your country. And this is how it looks. Really tons of metal, which is moving samples, and each one of the systems here can deliver between 10 and 20,000 results per hour. So there's a lot of blood samples moving along these tracks. And you even see a few people there. So this is how one of the example of systems looks like. So what we see there are some multiple pre-analytical systems which prepare the samples, like centrifugation, aliquoting, sorting. Post-analytical systems like, for example, storage and retrieval for the specimen in the tubes. There are the analytical systems. They are these systems which manufacture the results. They are usually controlled by a software, obviously, and they are exchanging a lot of data with the hospital or the laboratory IT systems and with Roche IT for making them running. So this is one of example, and I think at this point in time also few remarks. Roche Diagnostic and the entire business of IVD is strongly regulated by the medical device regulations, by privacy regulations. So the safety of the patients, the privacy of the patient data, also the safety of the operator. The instrument is not supposed to pick the operator with a needle which is contaminated with HIV or hepatitis, for example. So there is a lot of regulations going there. Second remark is we are international company headquartered in Switzerland, which means a lot of, let's say, Swiss traditions. First of all, related to federation. Federation means that we are not top-down driven company. We have a lot of companies which we are buying, and they are producing the systems, or there are partner companies which are producing the systems, and we need still to put them together in one system of systems. And we, the third one, remark here, we still need some facts, not the alternate facts. We need some real facts or some evidence for making our decisions. Another example of systems are the enterprise systems, and they are, as probably usual in enterprise, you have your ERP systems, CRM systems, on premises or in cloud deployed. They are running with various products, SAP, Salesforce, and so on. In our cases, they are also exchanging the data with up to 1 million devices, which are located all over the world. They are the medical systems, the IoT. Well, we are exchanging more data than the IoT is usually doing. So for this purpose, the definition, how we treat system of system, is actually taken from the art of the system architecting by Meyer. And system of systems is a system in which its components fulfill valid purposes in their own right and continue to operate to fulfill those purposes if disassembled from the overall system. They are also, bought or built for their own, developed for their own purposes, and we put them together. We integrate them into one system of systems. And this is the challenge, how to get a lot of systems which are not, manufactured, not with the intention being part maybe of the big system, how to put them together. So we were challenged, several years with these aspects, and we came with one method, and I'm just sitting for you because, I put together part of this method. By the way, Chief Software Architecture, as Jörn kindly introduced me, means it's the direct translation from German Mädchen für alles, which means like the general factotum. I can cook and I can wash and whatever it's necessary in this company in terms of the architecture. Therefore, I will walk you through the method which we just simplified there. We are not mature company, for example, to use the entire TOGAF or the entire Department of Defense architecture frameworks. Use a very complex method. So, and obviously we try to run our projects on various sites with various partners with agile processes. Therefore, we needed to have something simple. I walk you through the method about the business function allocation interface definition, which is at the starting where how we try to design the process. What is the method doing? It supports the allocation of the functions, what the name says, to specific system components, and actually supports the interface design baseline, which means defines the events and the data resources. And it consists of 6 steps, which I will just walk you shortly through. And by the way, if I'm using a vocabulary or you have a question which helps you understanding, feel free to interrupt me. Obviously, for discussion and general questions or critics about the method, let's move it at the end, but just questions about understanding, feel free to ask anytime. Good, so let's look at this and first of all, the documentation of each of the steps. Each of the steps is defined as a process, which means we have participants, we have pre and post conditions for entry and exit from this step. We have input, output artifacts, we have activities. If it comes familiar with you, it means that you are using, say, methods, for example, like architecture trade-off analysis method, because also the form and the content is specific for this, what we are doing here, but the form in terms of structuring is borrowed from, say. And the participants in this method are specifically targeted as a very small core team. 2 people. There is really, literally 2 people on the core team just because of the speed which we need here and easiness to do it. And there's somebody who has the knowledge of the business process which we are trying to implement, and the architect. We have also an extended team. The extended team is for delivering the deeper knowledge about, the process, the business, and it has stakeholders and also the architects of the systems surrounding or the business processes surrounding this one, so usually solution architects. The first step in this method is just look at the domain analysis. So this is mostly collecting of the information activity. We are just collecting the business drivers, the value proposition, the value stream, the business functions, we would be happy actually to use one of these methods here. All of the workflows constraints, also known issues from whatever the business processes currently are working, because a lot of this is improvement of existing business processes, and the quality attributes. So this is the first step. It takes, depending how mature, developed is the, or defined is the business process, from few days to around 6 weeks. So we have a spread here of the, in our, let's say this is our experience, probably it can be company specific. But from 2 weeks to 6 weeks is the average usual spread in our case. The next step is integrated dynamic modeling. And if you are not familiar with this well, abbreviation or this designation, it's a very simple model. We have events which trigger activities which are performed by performers to produce and consume the resources, the data objects, in locations under specific rules and conditions. So it's actually, this is based on the Department of Defense architecture framework, the conceptual data model. It's very simple, and we are using it because of its definition of the business, and we can work with the business analysts at this level. What we do during this modeling is, we capture it as a, well, as you can see here, the activity diagrams. It probably SysML would work maybe better, but at this point in time, we just have license for in enterprise architects only for the UML. So we are using EA tool, but you can use any tool which helps you modeling activity diagrams. So this is the first step. And this is because the core team is so small, this step is very fast. It takes usually around 3 days for a business process to model it fully within the activity diagrams. And we have on average 6 diagrams, as you have seen, per business process. I mean, obviously the complexity of business process can be organizationally different. I give you some values from our, from our experience. So, and we have a lot of these workflows or this business process modeled in this step. So the next one, we call it derivation. And we are interested here in this step in getting the information for interface design, which would be in this case the events, resources, and the resource in specific locations. And for the functionality allocation in which system or the system component the functionality should be implemented. And for this one, we need the performers, the activities, the rules and conditions. And we have here the usual choice options. And if you have listened to the keynote today, the options can be difficult to overcome and put into the architecture. So what we are doing here, we are extracting this information, and actually, well, it's very simple. What we are doing, we are just exporting it from the enterprise architect to new CSV and using Excel for sorting, filtering, and grouping this information so that we have a better overview than the graphical. I mean, just it's condensed view of this events, resources, and performance, and so on. So we have a lot of these events, activities, resources, performance, and so on. The next step is the alignment step. When we are looking for the elements of common concerns for all the participating workflows. Here we are putting the first time the teams together. The core teams are jointly going to a workshop, and we try to identify first of all, the elements of common concerns. What are the data objects which we are exchanging, for example, we are dealing with? And this is also the objects are named. We don't look too much into details at this point in time. We are align the elements of common concerns. Aligning means that we are just looking, if the data is there, which all this or the participating systems needs there. Also aligning the naming of this, because some teams could use different naming and designations and so on. And we are consolidating it, the elements of common concerns, and elaborate like a big list or a big table listing these elements. Obviously, after this team, which they were kind of like influenced they still go and correct or adjust their modeling. This takes usually around, well, a little bit depends here as usual, but for us it's average 2 to 3 workshops of 2 to 3 days just to get through this alignment here per bigger process. And as an output, we have the table of these aligned elements, like all the vocabularies, the glossary, the catalog of the items which we are exchanging, and the functionalities which we want to deal with. Now, after this step, we go to the identification allocation, where we want to put this function which we identified there. And in this step, we are just evaluating the options first for only according to the business criteria. Can we afford implementing this functionality in, let's say, SAP, or do we put it better on the CRM system in Salesforce? Can we put it in the cloud? What are the commercial criteria? So not yet quality attributes, not yet technical, but rather the organizational commercial aspects of this in our case. And then we look at the high-level overview of the business process. When we have already allocated the function, we can paint the entire business process, what functionality happens in what system, what data objects will be exchanged between the system, and here's also some like the criteria. Obviously, we don't want to couple the systems too strongly, so rather use the interfaces which, or rather group the functionalities so that we are not exchanging too much data between the system because it's cumbersome. But sometimes sometimes can be also not, not good for performance and some other aspects. So, but we are still at the very not detailed level of looking at quality attributes. But we have as outcome of this the big paint of the business process. And then we look at this big painting, it's usually a lot of flip charts and so on, with our stakeholders. This is the extended team. They are already participating in the workshops to some extent, but at the end we say, well, look guys, can you identify your needs with the process what we painted? So this is like the first filter of this. So this was the identification allocation. And then, well, then it's actually our usual job starts. There's the architecting for for the individual systems and or the interfaces. So we are architecture, the data models, process models, deployment models, interface designs. This is what all of us, or most of us, are doing, let's say, in our daily jobs. I'm not going to detail in this point because this is where we really are. This method actually is leading up to this point. And after this job and after the interface design, here is where we are just verifying the quality attributes. Obviously, we do all of this to fulfill the quality attributes, so they are present. But at the end, we have a review, and after the review, we can return to the identification allocation if we cannot fulfill it because of performance or some other criteria. It's simple enough, isn't it? So what is our experience summary? You see the method painted here. It looks probably more scary than it really is, all these 6 steps here. We applied it at Roche to the business process related to remote solutions and IoT. And for us, IoT usually transfers the information from the sensors to somewhere to your enterprise. Well, we are transferring a lot of information to our systems. So we have, the exchanges are not small messages. We are exchanging gigabytes per day with each of the systems, and the systems can be like several hundred thousands. So the remote solutions are complex thing. The data is coming from chemistry production systems through the regulatory relevant country-specific filtering and business logic, and finally to the distribution technically to thousands of systems. So we applied it there. It allowed us quick definition of the models and deriving of the data, and this is probably thanks to the teams because they were small. It seems to be shown well as a good support for the decision-making process. We have identified the common resources. We, had the data object catalog and the glossary, we have been able to allocate the functions to the corresponding system or system components and the resources, and we could identify the events and the data objects used in the transfer. And as I mentioned, at some point in time, we are applying agile processes in the development of the functionality for the specific system. Some of the systems are, based on technology on the market, like I mentioned, SAP or whatever, Salesforce. Some of them are, homegrown. So, and obviously the instruments are also homegrown, internal development software. Therefore, we have agile development there. You can use this method because it's like upfront, and it's not too much upfront design, in our opinion. So you can use it in agile processes within the development of the functionality in your system. And obviously, if your process, if your project is oriented on a process, the entire process could run agile too. We are not yet finished with these remote solutions. We are at some, let's say, in some of the systems, the implementation is underway. Some of the systems are yet still architecting. So, well, I can maybe report later, a year later or 2 years later, what was the final experience with it, but it's experience so far. Thanks for your attention.
Questions? I was just curious, you described some of your steps as being somewhat lengthy, like 6 weeks to do the one on the process and so forth. Have you guys ever been successful in taking this overall process and squeezing it down to being more condensed so that it actually fits inside of, let's say, a 3-week sprint?
Well, the challenge here is the organizational challenge, getting usually the stakeholders in a room. We are a bigger company. The stakeholders are spread all over the, let's say, 3 continents. And this is the major challenge why we need to have, workshops on certain schedule. Another point is that we just feel that if you have like 2 days workshop, you still need to digest this data. You need to process something, and then you have like a week later or maybe 2 weeks later another 2 days workshop. We just didn't even try to do it in 3 weeks sprint because for our organization would be not doable. I'm not trying to say that it's not doable for company being, on one side and having strongly committed stakeholders to a very focused project, but it's not true for us.
Hi. It's in your initial team that you had the business analyst and the architect, just the 2 people. It seems to rely very heavily on the knowledge and experience of that business analyst. How do you get around maybe a less experienced business analyst?
Okay, I named this role business analyst, but it sometimes is the experienced stakeholder or the project manager, and we have in the background, maybe you have seen the extended team. So when the business analyst does not know something, he or she can still call or make a meeting or get the stakeholder on board for this specific question. So this is how we proceed. But just we are here really oriented on speed of this generating these models. Because, okay, actually at the beginning, this was where a lot of the stakeholders have seen it as the major, how you can get the modeling so quick? And we just wanted to prove that we can. So therefore we just put in a small team and it worked in our case.
To what extent are you dependent on configuration management databases or other descriptions of your existing architecture? Okay,
yes, we are. The point is that we are dependent here very, 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 very much on this one. And this remote solutions actually is one of the projects to fix the drawbacks or the points which we don't have the right. So part of the remote solution is exactly to fix the configuration management part. But we are dependent strongly. Good catch.
Anyone else? Okay, then thank you,
you.
Andrzej.